Green Internet of Things for the Smart World. With the rapid development of science and technology, the world is becoming smart. People are automatically and collaboratively served by smart devices, by smart transportation, and by smart environments. All aspects regarding people's cyber, physical, social, and mental world will be interconnected and intelligent in the smart world. Internet of Things targets to connect various objects with unique addresses to enable them to interact with each other and with the world. Green IoT targets a sustainable smart world by reducing the energy consumption of IoT. This paper focuses on green IoT and studies various technologies towards green IoT. The hot green information and communications technologies consist of 5 technologies. We'll also look at a summary of general green ICT principles and the latest development in sensor cloud. The main contribution of this paper is enabling green IoT and discussion of the green ICT and principles.
Deifications. 2 of them are ITUT, which means International Telecommunication Union, and IERC, which is IoT European Research Cluster. Definition of ITUT is the technological and societal implications. IoT can be viewed as a global infrastructure for the information society. This include the identification, data capture and processing and communication capabilities. Further, the IERC, which included specific physical facilities and virtual communication, integrated into the information network through intelligent interface. Overall, the definition of the IoT is everything connected. Because the Internet of Things requires all terminals to have sensors and processing chips, it requires more energy. In order to reduce greenhouse effect energy saving and emission reduction, the energy consumption design will be considered. So there is a concept, Green IoT. This concept includes 5 elements: identification, communication technologies, computation, services and semantic. Certainly, the Green IoT has a wide application, such as smart home, industrial automation, smart healthcare, smart grid, smart city and so on.
Informational communications technology encompasses any facility, technology or application. This paper looks at various communication networks and services. To make RFID tags more green, then the devices could be miniaturized to reduce the amount of non-degradable material and made more energy efficient by developing more efficient algorithms. Wireless sensor networks consist of a base node and a network of spatially distributed autonomous sensor nodes. To produce a green system, these nodes could utilize the device's sleep mode, spend less time working, harvest energy from the environment, optimize the radio transmission techniques, and adopt data reduction techniques. In cloud computing, the resources are seen as services which allow users to share a large managed pool of resources. To reduce the environmental impact these shared resources produce, adoption of energy-efficient hardware and software could be used, power-saving virtual machine techniques, and effective energy-efficient models and evaluation approaches.
M2M machine-to-machine refers to direct communication between devices using any communications channel, including wired and wireless. Such communication was originally accomplished by having a remote network of machines relay information back to a central hub for analysis, which would then be rerouted into a system like a personal computer. With the massive machines involved in M2M communications, we should focus on how to increase energy efficiency. Here are some techniques to improve M2M energy efficiency. A distributed control system, DCS, is a computerized control system for a processor plant, usually with a large number of control loops. The main job of control system is to store, manage, process and disseminate various data and applications created by users, things, systems. So it means DCs consume huge amounts of energy with high operation cost. Here are techniques to improve DC's energy efficiency. As we introduce the green ICT enabling green IoT, we should following the below principles.
The sensor cloud is a unique sensor that can transmit data from sensor network provider to cloud service provider, where the information is stored and processed. After storing and processing the sensory data with data centers, it is delivered to cloud service user on demand. Recent developments includes a novel sensory data processing framework that is proposed to integrate WSN with mobile cloud that will deliver desirable sensory data to the mobile user in a quick, reliable and secure manner. Also, the CLSS mechanism has been developed to use the energy of the sensory cloud efficiently. This would require integration of WSN with MCC. To provide a better sensory data transmission in sensor cloud, a scheme called TPSS is designed that would offer more useful data to mobile cloud from WSN, resulting in increased reliance. Future sensor cloud predict that it will evolve into social sensor cloud, where the social networks will be connected with WSN and cloud, and all of them would be complement to each other. This would substantially reduce the resources and services requested by the sensor cloud user, resulting in dramatic decrease in energy consumption.
The design of green IoT should be tackled from an overall system energy consumption perspective. Characteristics and service requirements of different IoT applications need to be better understood. Realistic energy consumption models of different parts of IoT systems are needed. A virtualized sensor as a service may be envisioned, in which users have access and control to the virtually private IoT. To conclude, various technologies and issues were discussed concerning Smart World and Green IoT, including 5 hot Green ICT, with a summary of general Green ICT principles. We also covered the latest and future developments of Sensor Cloud.